All right, this is our first video for Unit 2, the elements and their table. And the first section in Unit 2 is titled Atoms and Element Squares. So that is where we will start. Just to redefine matter for a second, it's just anything that has mass and takes up space. And that pretty much encompasses everything we can touch, see, taste, and feel. So that's matter. We also need to understand that the tiny little things that make up matter are also matter. So the tiny little things that make up all we can touch, see, taste, and feel, they're matter as well. So these things are going to be called atoms, as we discussed in class and as you know from previous courses. And just a definition that we'll get down in the books is that atoms are the building blocks of matter. They're what make matter. So atoms aren't all created equal. We have a lot of different ones. And if you kind of look at the periodic table in the lower right-hand corner here, you see 118 different squares. And the atoms that would fit into each one of those squares all look a little bit different. If we have a collection of nearly identical atoms, we define that collection as being an element. So if we have a collection of hydrogen atoms in a box, we would say we have the element hydrogen in that box. And these elements are organized on the periodic table. Now there's a very specific organizational theme that goes on here. Actually, there are many themes, and we'll discuss those a little bit later on in this chapter. So you'll understand why the table actually looks why it does. So the element symbols are things that we worked on in the PhET simulation, and now we just want to get those definitions down in our notes for good. First of all, the atomic number. The atomic number is going to give us the total number of protons, and I'm going to draw a line to that at the end of this slide. The atomic mass is going to give the average mass of the isotopes of an element. And the isotope, if we aren't incredibly clear on that definition, are just an element that has the same number of protons but a different number of neutrons. So if you've got two elements and they both have the same number of protons, by definition they're the same element. They're both oxygen. But they can have different number of neutrons. So we can have one oxygen atom having one oxygen atom having 8 neutrons and another oxygen atom having 7 neutrons. The mass comes almost 100% from the protons and the neutrons. The electrons are so tiny that they offer just a negligible amount of mass to the atom, so we omit it when it comes to the mass number. So again, the atomic number is going to be this guy right here. It's the whole number. And again, that is going to be equal to the total number of protons that I have inside that particular element. If I change that number, I change the element. So for instance, if oxygen's protons change from 8 to 9, then we actually have one more proton, and so we have a totally different element. All right, sorry, I had to pause there for a second. Mr. Johnson came in and we were chit-chatting football. Okay, so let's see. Atomic mass is down there. That's on the bottom of those elemental symbols. And then the way you recognize the atomic mass is it's usually, well, I shouldn't say usually, it's never a whole number. It's never a whole number. It's always got a decimal after it. Okay, so that's going to be your atomic mass that's down there. Now, the definition of the atomic mass is it's an average mass. And it's an average mass of isotopes of an element. So you might be asking, what are isotopes? Well, we did it a little bit in the PhET simulation, but isotopes, an element that has the same number of protons but a different number of neutrons. And we're going to do a lab in class to more closely look at what it means to be an average atomic mass. Okay? The mass of an element comes strictly from the protons and the neutrons. And as I've said it before, the electron is so tiny, it just adds such little mass that we don't even consider it when it comes to the average atomic mass. All right. So moving on, let's go to ions. So ions, defined as a different number of protons and electrons. If you've got a neutral atom is defined as having the same number of electrons and protons. So if you have 7 protons, you have 7 electrons. If you are to lose one of those electrons, if you're losing an electron, you're losing a negative thing. So the electron it's going away, you're becoming positive. Because if you think of it, if you're losing something that's negative, you become more positive. And in that case, we actually call that a cation. So it's a C-A-T-I-O-N. It's called a cation. And the easiest way to remember that is there's a plus sign in the name, cation. If you are gaining an electron, so let's go the opposite way. If the electron is essentially being absorbed into the atom, so here's your atom, and it's being absorbed into the atom, Then you're gaining another electron thing, so then you become negative. So that's the anion. It's a different type of ion. All right. Okay. So if you got more protons than electrons, it's positive, and we call you a cation. If it's more electrons than protons, then you're negative, and we call you an anion. All right, lastly then, nuclear symbols. So nuclear symbols, as you saw a little bit in the PhET simulation, look like this. Let's take a carbon atom, okay, and then a 1 plus up there. And then let's go ahead and just define what all these things mean in a nuclear symbol. The number down here, again, that's going to be the atomic number. And the atomic number is going to tell us the total number of protons. So this equals protons. The number in the upper left-hand corner, this guy up here, this is going to be, again, the atomic mass. Okay, and the atomic mass is going to be protons plus neutrons. And then finally, we've got this little charge here. So the 1 plus, sometimes you actually may see it written as plus 1. They both mean the same thing. That's the charge. And so when you see that, you have to think to yourself, okay, if it's positive, that means I have more protons than I do electrons. Well, how many protons do I have in carbon? Well, I have 6. So if I have to have 1 more proton than electron, that means I must have 5 electrons. So the charge is the relationship between protons and electrons. Notice I didn't say it's the sum of protons and electrons. It's just the relationship between the two. So one thing that I'm going to ask you to do, and we saw this in this PhET simulation, is to, I'll give you an elemental symbol like this, and I'm going to say how many protons, neutrons, and electrons are there in this particular sample. So for this one, for protons are always the easiest because it's always that number. So protons are 6. For neutrons, all you got to do is take the atomic mass and you got to subtract out the atomic number. And if you do that, again, you get 6. Now, those numbers aren't always going to be the same. They just happen to be for this example. And electrons are going to be the hardest of them because, again, that refers to this little charge here, which often is going to goof up a lot of people. And the way, again, you think about it is that, okay, we got a positive charge, meaning I got to have more protons. How many more protons? 1 more proton than electron. Well, if I have 6 protons, that must mean I have 5 electrons. If you can do that, you know how to work with nuclear symbols. So I'm going to give you one. Let's give you, bam, 23, 2 plus. And I want you to pause the video right now, and I want you to go ahead and try to figure out how many protons, electrons, and neutrons there are in this guy, and then I'm going to come back and I'm going to give you the answers. All right, so here we go. Protons, 12. Neutrons, we've got 11. And electrons, for this case, we've got 10. So if you got 12, 10, and 11 there, you're all set. All right, that's 2.1.